Hello and welcome to our discussion on Herbert Ebbinghaus and memory research for our history and systems. My name is Jason E. Clark, and this is also presented with Jessica Conway, Hannah Dufresne, Jaden Johnson, and Ashton Stanfield's contributions. Today we're going to discuss who Ebbinghaus was, his contributions to the forgetting curve, the replication of the forgetting curve, the savings method, why the savings method matters, the modern applications and historical contexts of Ebbinghaus's work. First, Erwin Ebbinghaus was a German psychologist who pioneered the way in the studying of memory. He was born on January 24th of 1850 in Germany to a wealthy family. He did attend the University of Bonn until his studies were interrupted during the Franco-Prussian War, at which time he served in the Prussian army. After the war, Ebbinghaus returned to the University of Bonn, where he earned his doctorate. After completing his education, he conducted self-experiments in an effort to study memory and subsequently how people forget things. This leads Ebbinghaus to develop the forgetting curve and the meaning of spaced repetition, as well as the savings method. The forgetting curve is a concept developed by Ebbinghaus that shows how memory fades over time when information is not reviewed or practiced. This curve demonstrates that forgetting happens very quickly at first, and in the hours and days after learning something new, we lose a large portion of that information if we don't revisit it. However, as time passes, the rate of forgetting does slow down. The information that remains in memory becomes more stable and forgotten more gradually. Ebbinghaus's forgetting curve fundamentally relays the importance of reviewing the material soon after relearning it to strengthen memory and to improve long-term retention. More than a century after Ebbinghaus conducted his original experiments, researchers Muir and Dross revisited his work to examine whether the forgetting curve still held up under modern analysis. They reanalyzed Ebbinghaus's original data and found a very similar pattern of memory decline over time. Their study confirmed that people do tend to forget information rapidly after learning it, followed by a slower rate of forgetting. This replication is important because it does provide modern evidence supporting one of the foundational findings of memory research. It also shows that the forgetting curve just remains a reliable explanation of how memory changes over time. These researchers were able to replicate Ebbinghaus's findings of the forgetting curve because his developed measures of memory retention were both replicatable and reliable. This measurement technique would become known as the savings method. The savings method, initially developed by Ebbinghaus, is a way of measuring memory by looking at how much faster something can be relearned compared to when it was first learned. So instead of only testing whether someone can recall information or not, it focuses on how much time, effort, or number of repetitions are saved when a person learns that same material again. In his experiments, Ebbinghaus listed nonsensical syllables so that prior knowledge and meaning would not influence the results. A controlled experiment. He would first learn a list and then wait a set amount of time and then try to relearn the same list under those same conditions. The difference between the original learning and the learning of what is measured as savings, and it gives an estimate of how much information was still stored in memory even if it couldn't consciously be recalled right away. The savings method is what gave Ebbinghaus a reliable way to measure memory retention, but it is important to know that it goes beyond simply calculating savings. Researchers Muir and Dross demonstrated that. Understanding why the savings method matters helps explain its lasting impact on memory research. The savings method matters because it shows that forgetting is not always a complete loss of information. So even when someone cannot consciously recall something, some trace of that memory does still remain, making relearning faster and easier. So for example, if a list only took 25 repetitions to learn, but only 20 repetitions to relearn later, the 20% savings is suggested that some of the information was still stored in memory. So this actually helps explain why information can feel familiar even when it cannot be fully remembered. The savings method also changed how psychologists study memory by introducing one of the first objective numerical ways to measure learning and retention. So instead of relying on descriptions or guesses about memory, researchers could use memorable data such as time saved and repetitions needed, which help establish memory research as a scientific field and influence later studies on learning and forgetting. So what became as a method for studying nonsense syllables in the late 1800s ultimately helped shape the development of memory research, making its historical impact and modern applications worth exploring today. Modern applications and historical contexts, Ebbinghaus's findings have formed the foundation of memory learning studies and are still used today. The forgetting curve is used to improve many educational techniques that are still used in schools. The savings method measures memory over the passage of time. Before Ebbinghaus, memory was actually studied through philosophy, not using scientific experiments. He's actually the first psychologist to use controlled experiments to study mental processes. The memory of experiments pioneered by Ebbinghaus allowed researchers to further refine memory research. So, to wrap it all up and bring it home, in conclusion, Ebbinghaus was a German psychologist and a Franco-Prussian war veteran who pioneered the studies of memory and forgetting. The forgetting curve is a concept developed by Ebbinghaus that shows how memory fades over time when information was not reviewed or practiced. 100 years later, researchers Muir and Dross replicated Ebbinghaus's findings to demonstrate the forgetting curve is still relevant. The savings method gave Ebbinghaus a reliable way to measure memory retention, but it is important to remember that it goes well beyond simply just calculating savings. Understanding why this method matters helps explain its lasting impact on memory research. The savings method matters because it shows for the first time that forgetting is not always a complete loss of information. When someone cannot consciously recall something, some trace of that memory will still remain, making relearning faster and easier. Before Ebbinghaus, memory was studied through philosophy, not using scientific experiments. Finally, we do affirm that this presentation was created by all of the group members and that all of its contents are based on the instructor-approved articles and the textbook, not solely on our opinions or beliefs, and we have included citations. We further affirm that no part of this presentation was plagiarized. We understand that plagiarism includes copying, paraphrasing, or closely imitating any person's words, ideas, or media without proper acknowledgement, as well and in particular presenting AI-generated or other external content as our own work. AI tools, if they were used, they were only used for grammar and proofreading, not to generate ideas, content, or structure. Thank you for your time. Have a lovely day.